In this concept video, we're going to talk about how to perform functional analysis. And we're given this function here, a of x, looks to be a rational function, rational equation. When you think about functional analysis, what you want to do is you want to start thinking about what things would help to graph the equation. That's going to be a starting point. Then we're going to use the graph of the equation to help us determine a few other things. So when I look at a situation like this, a rational equation, I'm going to want to know a few things when I'm graphing. One thing I'm going to want to know is if there's any vertical asymptotes or holes, if there's any horizontal asymptotes, and then also what the x-intercepts or y-intercepts will be. So let's take take a look at the first one here. We're going to investigate whether there's any vertical asymptotes or holes. When we do that, what we want to do is factor the top and then factor the bottom separately. So we'll do vertical or holes right here. So if we factor the top, we want two numbers. When we multiply them, we get negative 18, and when we add them, we get negative 7. So I think that's negative 9 and 2. So the numerator can be factored into x minus 9 and then x plus 2. And if you need to check, just do your foiling. You do it right in your head probably. Negative 9 times 2 is negative 18. Negative 9x plus 2x is negative 7x, so we're good to go there. And then in the denominator, we're going to have two numbers multiplied to get 6, but add to get 5, so that would be x plus 3 and x plus 2. We're going to notice a couple things here. One thing we notice is there's the same factor in the top and the bottom, and so we know that this is going to be a point discontinuity or a hole, and it's going to be at the value that makes this factor 0. So you can set that equal to 0 and solve, but we can easily see here that at negative 2 there's going to be a hole. The other one, x plus 3, the other factor that doesn't have a factor in common with the top and the bottom, that is where your vertical asymptote will be. So in this case, there's going to be a vertical asymptote at negative 3. And this will be x is equal to negative 3. Remember, this is a point, and this is an asymptote or a vertical line. We can go ahead and draw that over here in the graph. So I like to use either, if you're drawing in pencil, just you can do it lightly if you want to. Here, though, of course, with a Sharpie, I'll use dots. We're going to just remember this, that there's a hole at negative 2. We don't know exactly what the graph looks like just quite yet. We're just kind of investigating it. We're analyzing the function. The next thing we can do is a horizontal asymptote. So for the horizontal asymptote, we want to take a look at the leading term in the top and the leading term in the bottom. We need to make sure that both the numerator's leading term and the denominator has the same exponent, or the degree of the polynomial is the same. If it's not, then we can add a filler. In this case, it is the same. So we can just write, and I'm going to put 1x squared in here so you can see how this works, and 1x squared. And then we can simplify this. The x squareds will cancel, and we'll be left with y is equal to 1. In this case, it's a horizontal asymptote, and so we'll have 1. So just take a look at your leading terms here in the numerator and denominator, and make sure they have the same degree. If not, if you had just an x up here, you could add a 0x squared in the numerator. And then if you get 0 divided by some number here, your asymptote would be y is equal to 0. If these two are the same, in other words the degree is the same, then you just take a look at your leading coefficients, which in this case is a 1 and a 1. 1 over 1 is 1. And then if you ever end up in a situation where you get division by 0, let's say this x squared wasn't here and you'd had to add a 0x squared as a filler, that situation would be division by 0, and so there would be no horizontal asymptote. Another thing to keep in mind is a slant asymptote. Slant asymptotes will occur only when the degree of the numerator is exactly 1 more than the denominator, and that's not the case here, so we don't have to worry about it. So we're going to go ahead and graph y is equal to 1, which is a horizontal line right through 1, and there's our horizontal asymptote. Some other things that we can do when we're graphing this guy is to find any x-intercepts and y-intercepts. So when we talk about the x-intercepts, if we look at our original equation here, if the numerator is 0, then 0 divided by any number, as long as it does exist, so as long as this denominator is not 0, then 0 divided by any number will be 0. And that's what we want for y. When we're trying to find our x-intercepts, we are substituting 0 in for y. So we're going to have x squared minus 7x minus 18 is equal to 0. Don't do any more work than you really need to. If we take a look at this right-hand side when we were asked to find our vertical asymptotes or holes, we already factored the thing, and we're going to need to do that to solve this one. So all you need to do is set the numerator equal to 0 to find your x-intercepts. We've got it already in factored form. So x will be 9, or x could be -2. We know that actually -2 won't work because there's a hole at -2. So I'm going to cross this one off. So these are just the possibilities right here. But in this case, the graph is not going to intercept the x-axis at -2 because it doesn't exist at -2. So that would be a case where you would have like 0 divided by 0, which would be bad news for us. But we can put a dot at 9. And so if we put a dot at 9, we can just go 1, 2, 3, and I'll tell you what, as a matter of fact, let me switch colors for you so that you can see what the actual graph looks like, because right now these asymptotes actually are not part of the graph. So we'll go right 9, so we got 6 and then 9, and we can begin to actually start to build our function here as we figure some spots where the graph will cross the axes, in this case the x-intercept. The y-intercept is a little bit different. To find the y-intercept, all we're doing is substituting in 0 for x. So if we take a look, we've got 0 squared minus 7 times 0, well that's just 0, so we'll be left with -18 in the numerator. And then we've got 0 squared plus 5 times 0, and that's just 0, and 0 plus 6 is 6. So when you substitute in 0 for x, what it essentially does is it kind of removes all the terms with an x in it, and you're just left with the constants. And if you want to think about it like that, you can. Mathematically, all that's happening is you're taking 0 minus 0, and you get 0. So you're just left with whatever's on the right-hand side, the constant there. So the y-intercept will be -18 divided by 6, and in this case that would be -3. So remember, this is a point. I probably should do that here for the x-intercept. We'll move this up a little bit. That this point is 9, 0. When we're finding an x-intercept, we're finding an actual point, not a line. And then for this one here, we've got 0, -3. So in either case, you're going to have 0 in either the x or y position. If you're solving for the x-intercept, it'll be in the y position. For the y-intercept, it'll be here in the x position. And we can use the green marker here to indicate that 0, -3